Welcome again, Wildcats. All right, so today we're looking at Wednesday, January 11th, imaginary numbers and complex numbers, and that's going to be on page 43. So if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's look at our notes. All right, so an imaginary number is a number that is expressed in terms of the square root of a negative number. So I equals the square root of -1. For an example. Now, let's take that, and as we know, in an equation, we can do whatever you want as long as we do it to both sides. So in this case, let's just square both sides, okay? So you get I squared. Now we know that the squared and the square root, they become -1 to the first power, so we can now say I squared equals -1, okay? All right. Let's now look at complex number. Is a number that can be expressed in the form of a plus bi, where a and b are real numbers, and I equals the square root of -1. Now, every complex number has a real part a and an imaginary part b. The real part is a, and the imaginary part. Now, I know we said here b is a real number. Now, b is a real number, but bi is the imaginary part. Okay? All right, so if you would, update your notes. All right, now let's look at the examples. All right, and at this point, you might grab some colors. So I'm going to make A green, B pink, and I think C blue. All right, so let's graph these points. All right, now, what you want to notice is that this is the real numbers, and these are the imaginary numbers, okay? So A technically is 2 plus 0i, okay? So we go to the right 2, but we don't go up or down because there's no imaginary part to that. So that's point A, okay? Now this is technically written as 0 minus 3i, okay? So there's no real part, so we go down to 3i, and that's point B. Now C has a real part, so we go to the right 2 and up 4i. 1, 2, 3, 4. And that's point C. All right, I'm going to graph D and E in class tomorrow. But I would think that you could graph D and E before you get to class, but I'll graph them in class so you can verify you're correct. All right, let's look at simplify the expression. So let's look at example 2 and example 3. All right, so first off, since there's no number in front of the parentheses, we don't need the parentheses. We can ignore them, okay? If there was a number in front of the parentheses, then we'd have to. All right, so here we're going to combine terms. So I see that -2 and 3. Now we're going to combine the i's. So plus 4i minus 11i. Okay? Now the reason what I did that is because -2 and 3 are real numbers and 4i and minus 11i are imaginary numbers, and you can't combine them. But we combine these. So -2 plus 3 is 1, and then 4i minus 11i is minus 7i. All right, now here we don't have a number in front of the parentheses, so we can just write that as 4 minus, I'm going to put a 1 in front of the I. But now here you have a -1 in front of the parentheses, so we need to distribute that. So -1 times 5 is -5, and -1 times 8i is minus 8i. So again, combine terms, so 4 minus 5 and -1i minus 8i. So 4 minus 5 is a negative 1, and negative 1i minus 8i is negative 9i. All right, so you can do example 4 and 5 now, and then I'll go over those in class tomorrow. All right, let's look at example 6 and 7. All right, parentheses mean multiplication, so we multiply. Negative 6 times 5 is negative 30. I times I is I squared. But, and I did this on purpose, I showed you that I squared is negative 1. So this is negative 30 times negative 1, so that equals 30. All right, example 7. There's a number outside the parentheses, so we need to distribute. So 2i times 3 is 6i. 2i times negative 5 is a negative 10, because 2 and 5, but I times I is I squared. And remember that I squared is negative 1, so that's negative 10 times negative 1. Now, in a complex number, you always put the real number first. So negative 10 times negative 1 is a positive 10 plus 6i. All right, and then you can do example 8, and I'll go over that in class tomorrow. All right, example number 9. We have binomials, so we know that we're going to multiply using the box method. All right, drop my pencil. Well, broke one, threw that away, and got a new one. All right, so 5 minus 6i, 4 minus 3i. So 4 times 5 is 20. 4 times negative 6i is negative 6, 12, 8, negative 24i. Negative 3i times 5 is negative 15i. Negative 3 times negative 6 is a positive 18. I times I is I squared. So we get 20. We combine here. So negative 15i and 24i is negative 39i. Plus 18i squared, but I squared is negative 1. So that's 20 minus 18, which is 2, minus 39i. All right, and then you can work example 10 and 11 on your own. All right, so that should get you ready for a very imaginary and a complex day on Wednesday. So if you would finish up the examples and to have a terrific Wildcat Cheez-It day.